That's because it forms something called a ball and socket joint in your shoulder. The humerus makes up the ball, and your scapula helps make up the cavity that it fits into. It's called the glenoid cavity. So together they make a ball and socket joint. Very similar to how your femur and pelvis form their own ball and socket joint. Here is an example of a femur. You'll notice that they're really different in size. Your femur is actually a lot bigger. Another big difference about these, if you look at the balls or the heads of them, the femur actually has a really nice defined neck to it. While the humerus, it's kind of like Uncle Fester. He's like, no neck to it at all. So femur is larger and has a more defined neck. Humerus is smaller and doesn't really have one. But they both form the same kind of joint, ball and socket joint. Now if you move down your to your forearm, the antebrachial region, you have two bones that make up that, your radius and your ulna. So we'll start with the radius, or your thumb side, so it's more lateral. If this bone was sitting in front of you just by itself, one way that you could tell that this is a radius, look at the proximal head, the head that would be up here. Notice how it's pretty much like a perfect circle, almost like you could measure the radius of it. And so a radius has pretty much like a perfect circle on the head of it. So circle, radius. And another way to remember that it's on your thumb side, have you ever taken someone's pulse on the wrist like this? It's called their radial pulse. So it's thumb side. Now opposite of that, so more medial on your pinky side, that would be your ulna. And it's a little tough to see, but the head of the ulna right here, it forms kind of a U shape. Because what it does is it kind of curls itself around the capitulum of your humerus. So it kind of curls around it like this, and it forms a U shape. So anytime you see that U shape, think ulna. And you can come up here at some point and look at it for yourself, but that U shape is right there, and it curls around the humerus. So moving downward to the leg. We already went over the femur. Now it's time to look at these other bones in the leg area. It's like a dog peeing or something. All right. So you have two bones here. This really large one that's more medial, that's your tibia. If you look at the tibia, it has kind of a skinnier diaphysis, or the shaft of the bone, but it thickens out at the end, forms almost kind of a T shape. So tibia almost looks like it's a large T. You'll notice that it's a lot larger than the skinnier bone. Therefore, your tibia is your main weight-bearing structure of your leg. This other bone right here, the skinnier guy, that's called your fibula. Your fibula doesn't play much of a role in weight-bearing. It's more just there for muscle attachment, for the muscles in your legs. And you'll notice that these two bones hang off the sides of your foot. So your ankles are actually made up of two bones. One is made up from your tibia, one is made up from your fibula. So one is skinnier, one's thicker, and bears all the weight. All right, so that's just kind of a brief intro to bone anatomy. We'll be going way more in depth later on, but just some hints as to how to identify these. I know, it's so interesting. All right, I'd recommend taking pictures of the skeletal model and also the models up here, but you can get going on your labs. Again, the